In this next video, we want to be able to evaluate logarithmic expressions. The first video just focused on like translating from exponent to logs and vice versa. Now we actually want to evaluate. So our calculators, yes, there is a log button on our calculators. You can find it log. There's a very specific purpose for this. Okay, we'll mention that in a moment. So that button though doesn't work for everything. In fact, it works in very few cases. Okay, so let's do a little bit of thinking. I know, radical, right? The logarithm has some nice properties. Okay. These are some exponential properties, right? A to the 0 is equal to 1. We know that is true for all values of a. Well, that are positive. Whatever. It actually is true for negative as well. In any case, when we translate this to logarithm, i.e. use the tattoo, what do we get? We get log base a of 1 is equal to 0. Okay? So really what this means is that log base anything of 1 is always equal to 0. Huh, that's kind of nice. Similarly, this second one translates as log base a of a is equal to 1. Huh. So whenever the base matches the input, it's 1. Oh, that's nice. Okay. And then equivalently, we can extend this second to last property that we were talking about, and we can say that if it's log base a to the x, that's just x, so it's just the exponent. Again, base of the log must match the base of the exponent. And then similarly here, if you have, these are really weird expressions, but you can get them. It would be a to the log base a of x. Yeah, it's just x as well. Okay. Other definitions. If we have log base 10, we typically omit the base and just write log x. Okay, and that's called the common log. If we have log base e, we write that as ln, and it's called the natural logarithm, and it was actually it was derived from Frenchmen who named it, and so in the French language they reverse the nouns and the adjectives, so that's why it's ln instead of nl. Okay. In any case, the only thing that I want to make you aware of is that some textbooks, and I've encountered this many times, they write logx when they mean lnx. Okay, just be aware as you go on in your professional life. Okay, so now we want to use these properties, or at least what we can use from these, to evaluate each of these expressions. Okay, and here's my suggestion. Set it equal to x. You can always define this as a number x, and then you're just going to find the value of x, but this allows you to use the tattoo, or use the circle method. 5 to the x is equal to 25, and now, okay, you look at it for 2 seconds, you say x is 2. Okay, so that is just fine. Okay, and so really this is a fine final answer. This one, again, if you set it equal to x, 25 to the x is equal to 5. And again, you can think about this for 5 seconds, or if you wanted to think of this as, doing what we did in section 7.1, then we get something like 5 to the 2 to the x is equal to 5 to the first, and then we get 2x is equal to 1, or x is equal to 1/2. Okay. The next one, okay, I'm going to do for you pi is equal to, this is equal to x, so pi to the x is equal to square root of pi, rather. And so then x is going to be 1/2. Okay, so square root is 1/2 power, Okay, this one is just 0. Nice old definition to the rescue. ln of e, I want you to think about this and maybe do a little bit of work, but this should just be 1. Okay. And the last one here is going to be a quiz question. Okay. This one you will have to use the tattoo and get the same bases and all that stuff. Alright, so try that in the quiz.